We're now going to look at negative exponents and what this can mean for an expression. For any rational number m over n and any non-zero real number a, for which a is raised to the m over n and it exists, then if you have a raised to the negative m over n, this means that you would have 1 over a raised to the m over n. So here we have many laws of exponents and properties of rational exponents. So these properties of integer exponents also hold true for rational exponents. The rule says if you have a product of two bases that match, the exponents will add together. An example of this would be 3 squared times 3 to the 4th, and that will give you 3 to the 6th. Rational exponents do the same thing. When you multiply the bases that match, 1 over 4 is an exponent on the first, and 3 over 4 is the exponent on the second. If you add them together, you get 3 to the 4 over 4, which is just equal to 3. So go ahead and look through these. The basic idea is that the product and quotient rules for integers also hold true for the fractions. If you have a power raised to a power, this means that you would multiply one exponent to the next exponent up. If you have a power of a product, that means if you have two different factors as the base, and they're both raised to the same value on the outside of your parentheses, then you can distribute that exponent to both bases. And then also power of a quotient. Hopefully this is also ringing some bells. If you have a fraction raised to some power, then you can distribute that value, that integer, to both the numerator and denominator, and then reduce it. So the same idea holds for fractions as exponents. You can distribute that fractional exponent to both the numerator and denominator, and then simplify if you can. If not, just leave it as a radical.